2021. Our first speaker today is Mr. Michael Demey. He is the research manager for iText software. He'll be now joining me on screen. Take it away, Michael.
Hi, Marcus. Thank you for the introduction. Okay. Hi, everyone. Thank you for joining my talk, Speaking in Different Tongues, in which I will talk about stabilizing and synchronizing our code bases. Before we begin, I would like to thank the organization for hosting this event in these trying times. There are lights at the end of the tunnel, but we still have to meet in a virtual capacity. But these are very viable alternatives. I'd like to thank the organization and Marcus as well for hosting and supporting us in this regard. So maybe first a bit of an introduction as to who I am so that you know what my role is in this story. My name is Michael Demey. I am the research manager at iText. I've been employed by iText for close to 10 years now, starting first as a support engineer and now I'm the research manager. I'm in charge of a small team that is dedicated and motivated to innovate at iText. So we prototype, we do some rapid development on new concepts and new technologies to see where we can improve the competitive edge that the company has. In my free time, I'm also a bass player. As you can see on the picture, I love playing double bass. I'm a classically trained musician. I love to play tango and classical music, but also some dabbling into modern music as well. My other full-time job is being a dad of 2 kids. They're very awesome and very tiring, even more so than my daytime job. Down there is my Twitter handle. If you feel like following me, go ahead. I don't tweet often. I do reply to DMs. So if you want to talk about a concept that we talked about today, or if you just want to hang out or something, feel free to hit me up on Twitter. Without further ado, let me introduce the company a bit and the product, because that is the key of this story. iText is basically 2 things. First of all, it's a company, it's my employer. I give them code, they give me money. It's a very symbiotic relationship that we have that works perfectly fine. But next to that, iText is also a product. It's an open source SDK, meaning that you program code to create or manipulate PDF files. You can do that by writing raw code or by giving one of our products an HTML file that will automatically convert to PDF. There's multiple ways of using iText, multiple ways of using PDF. And this product has been around for close to over 20 years now. It's been around for quite a while. As the slide mentions, we have millions of users, we have millions of thousands of customers. People might unwillingly be an end user of iText technology. For instance, if you've ever downloaded a PDF file that contains your airline ticket, 9 times out of 10, that has been created with iText. Unfortunately, your tax form might also be created with iText, but we'll let that one slide. So iText is a product and a company, and we're going to look a bit at the product and how it evolved and how we dealt with certain issues related to the product. So 20 years of iText, this is something that we celebrated last year. Let me just turn on my pointer real quick. There we go. So the first public release was back in 2000. There's 2 major changes that we've done. In 2009, we changed licenses in order to build a sustainable license model that had a lot of work in the ground, and we changed a lot of things there. For iText 7, we reworked the entire library, the SDK, to make it more modular and to build a plugin system on top of that. So we've got a few add-ons, a few plugins that solve specific use cases like HTML to PDF or extracting data from a PDF file and PDF to data. Something that iText has always been very close from its inception, so I think it was around 2005 or something, is that we've always had 2 platforms on which we have released. So we have the Java platform, which is the initial platform that we developed for. And then we have the .NET platform, which is the second platform, second language that we've added. So on the .NET platform, we target the C# language, but it's a platform just as Java, so you can use it. on those platforms. The thing to note here is that both libraries are functionally equivalent, meaning that you can do the same things in C# and .NET as you can in Java, even though we are initially heavily focused on Java. This is something that you don't come across with multi-platform libraries, because sometimes they just take a subset of the main library in order to fulfill a specific need of a customer or a specific use case. But we made the conscious choice to have equivalent libraries on both platforms. And this brings forth a few issues on how do you convert between Java and .NET C#. Luckily, the languages are very similar on a syntax level, but also on an idiomatic level, on a how do you write the language, what kind of structures do you use. So that I would say luckily, but it's not coincidence that we chose C# as well. But there are also some things that you can't do in the C# version because of peculiarities in the Java, or because of historically organically grown features that we have in the Java build. But for all intents and purposes for this talk, we consider both libraries to be functionally equivalent. And the story of this deck, of this presentation, is how we deal with that and how we got there. It's basically a movie about having growing pains as an open source community, open source product. So story always has a beginning, and our story starts at the Olde Times. Back in 2011, when I joined, the company was just founded. There was only 5 people on the payroll. I was the 5th one to be on the payroll, I believe. And at that time, we had no real infrastructure. There was no automated build system. Every release that we sent out was built manually on the same machine. So meaning that version 1.00, let's say, was built on the same machine as 2.00, just for consistency's sake. But everything was mostly done manually. We had a scenario in place, like you have to perform these steps, but nothing was scripted. We had no real test suite in the way that, I mean that in the way of it not having a automated test suite. We did have tests back then. So Bruno, the original founder and developer of the Codebase, he wrote 2 books on how to use iText that relate to this story. And those books contained code samples. I would say a few hundred of them, maybe 200, 300. And every release, every build that we've done, the tests would be run automatically, manually, sorry. And Bruno, or the person in charge of the release, would check the output of those files of the tests to see whether or not there was regression, or there was an improvement, or the aspired improvement. But nothing was really automated. Nothing was really as it should have been. And there was no structured translation from Java to C#. Everything was done manually on a commit per commit basis. Also in a very unstructured way, in some kind of way it wasn't structured, which caused a lot of slowing down. And I'll explain to you how the process worked on the next slide. So when we were developing code, we would write primarily in Java. So we would write our Java code feature. So we would write a feature, we would try to fix an improvement in addition to the code, and then we would test it. Testing and building it, obviously, seeing if it still compiles, seeing if everything is still okay. This would loop back and forth, these 2 steps, until we decided that a build was in order. We would have to make a release. Then in this release, the manual steps that I outlined before took place. So what happened was there was a code freeze, and then we built the code manually using first initially Ant, then luckily we moved to Maven. Now we have this hybrid going between Maven and Gradle. And then the tests would be run manually on a machine, the same machine that built the Java code. If everything was okay, everything looked to be in order, then the release documentation was written up, and then the release happened for Java. All in all, this took about a week to 2 weeks, I would say. My memory is a bit hazy on that. It's been a few years. but it took longer than it should. But it was consistent. We got releases out for Java at least. But that's only Java, that's not .NET, that's not C#. At this point in time, we don't have anything written in C#. So what we've done then is, once the release is finalized for Java, we would go to the .NET Codebase, and then we would, for each commit, we would write a .NET code, and then we would test it until every commit that is included in the Java release was manually ported by somebody who drew the short straw, basically. Then we built it on a single machine. We tested it with the tests that we had, minimal amount of tests, and everything was okay. Then we would release it. This process also took about 3 weeks to a month, maybe. To keep in mind, we were a very small company at the time, with only a handful of developers. So if you're lucky, we're looking at a release cycle, or at least a release build time of about a few weeks in this outlined process here. The thing is, sometimes while you're converting your .NET code, your C# code, sometimes you stumble upon a bug. The developer who ports the .NET code, the Java code to C# sometimes finds a bug or sees that the output isn't how it should be. And you don't want to skip on fixing it while you're writing the .NET code, because you're not going to willingly release something that has a bug in it, at least not if you can help it. So what would happen is, once you've got the .NET code out, your seemingly equivalent libraries would be not equivalent because you've released a bug fix in .NET and not in C# and in Java. What would happen is that sometimes we would go back and then update the Java code and go through the build cycle for Java again, which took another week at most, depending on what we found. But that would mean that you would have, for instance, a Java 1.1.1 build, a .NET 1.1.1 build, but then also a version 1.1.1 in Java, because you have some patches that you found. As you can imagine, that was pretty cumbersome. It works to a degree. I mean, if it works, right? It's not stupid, but there were some aspects to it that could have improved. But again, it's a very slow process. You're looking at a month and a half, if you're unlucky. And throughout this, .NET felt like a second-class citizen, like an afterthought. Like we did have the code base available, so let's just keep on adding to it. Not giving it the priority and the importance that it has and that it deserves today. So the first change that we made was a new approach to coding. It's a pretty simple approach, one that would pull in the .NET porting into the Java writing code. So you have a task, a bug fix, a feature request, or an improvement ready, and the developer would start writing the Java code, start testing it as well. Once the testing of the Java code is complete, once you know that the feature is correct, he would immediately start writing the .NET code as well, meaning that the same person who wrote the code still has the idea, still has the technique, still has the code fresh in his mind to start writing the .NET code. And also testing it immediately, seeing whether or not new bugs appear in that feature. This would, again, repeat a few weeks, a few months until we decided to go to release. And then we would build the resources that we needed to go to release. Meaning we would build the Java jars, we would build the C# DLLs. Right then, this already cut back on the time on the release cycle, because you're not using time during the build, during the releases to start converting, translating code. It did mean that we did lose some time during development, because now all that time is being offset to the front of this huge cycle here. But all in all, it did shorten the release builds, and it made sure that we were a bit more predictable when we could deliver the deliverables for release. Then structurally, we added something that was very, very, very much needed and very much welcomed, and that was build automation. We used Jenkins, and we still use Jenkins as of today. We used a combination of Jenkins and TeamCity back then. So Jenkins, for those who aren't in the know, is a build server, build automation server. So you can configure, you can script your builds in Jenkins. It has plugins for most commonly used and also uncommonly used languages and processes. So we configure it to run Java and to run C#. It does so fine. This means that we can we save a lot of time on building. We don't need to do it on a single machine run by a single user. We don't need to wait on that user. We can run builds nightly. We run builds after every commit at that time. We also started writing a lot of tests. So we have unit tests, functional tests, regression tests, etc. And these are run automatically by Jenkins, which is an amazing time save as well, which also means that we don't have to spend manual resources doing that. Like the checking whether or not the output still looks the same as the older version of iText. That's something that we don't do anymore. We automated that as well. We have a tool called the compare tool. We ship that in iText core if you want to check it out. And basically, you can compare two PDF files on a structural level, but you can also compare them on a graphical level where you basically convert to a raster image, and then we check byte by byte or pixel by pixel whether or not they still look the same. So we save a lot of time on building, we save a lot of time on tests, we have a lot of predictability here. We know that as soon as we want to release, as soon as we want to press the release button, that the builds that we have, they work, they compile, they have the expected output. So that's a lot of time saving and risk that we averted. But we still lose time on translating Java to C#. We still had a lot of manual work to be done there. Still the old process of writing Java first and then .NET second. Usually on the same day or the day after, but you get my point. You're still doing double work. So we introduced another tool. This is a tool not written by us, but we did improve it internally. It's called Sharpen. Sharpen is an amazing tool. It's a library and a CLI for automating Java to C# code conversion. It is amazing. It does the job pretty well, not perfectly. It does it pretty well, but you do need to configure it heavily. It doesn't know how to handle certain things. Even though Java and C# are quite similar, you would still do things differently depending on which language you're using, which platform you're writing for. And not everything on the Java build was in the .NET build. I'm thinking specifically, so for instance, the crypto APIs are different in Java as they are in .NET. Java has this whole provider system worked out, whereas C# does not have that. And so to do those things, you would still need to configure a lot of things, and in Sharpen, you would need to tell it how to do certain things. One thing that you still need to do, there is still some manual conversion that needs to happen, meaning that we told Sharpen, here's this list of files. It's not a long list. There's a dozen or a few dozen files on there. And it tells Sharpen, like, these files, these code files, you cannot convert automatically. If you do so, it will fail horribly and the build will not compile. So there's still a need to do some things manually, and I don't foresee that changing, but we minimized it, and I think that's the best that we can strive for right now, unless somebody else has a better option. If so, please tell me in the chat. I will take your questions after the presentation, by the way. So yeah, Sharpen was configured, and that works great. You can run it locally. You can run it on your Jenkins server. It's great. So Sharpen was included in a step, in a build step that we call Autoport. Autoport is basically three steps that it does. So it builds the Java project. It checks out the repositories, so it pulls in the Git repo, it builds it, it runs the tests. Secondly, it autoports Java, meaning that it runs the Sharpen build. So it builds Sharpen first, and to see if it's got the latest version, and then it runs the Sharpen tool on the Java build that you've just run and tested. And out comes a .NET build. The code files are all in place, and then the build.NET step is being run. That step just compiles and runs the tests as well to see if everything is okay. It takes into account the manually ported files that you need to do as well. And then it makes a commit to the .NET repository. So you would have two equivalent commits, one in Java and one in .NET. And the .NET one has a link to the original commit in the Java repo, just to make sure that we have that link available. We've also introduced some changes at that time. We started using in Git, so we started using Git flow. Git flow is a process where that tells you, or at least advises you on how to manage your Git repos, your code bases, where you would have a main branch and a develop branch. The main branch houses all your versions, and the develop branch houses your currently ongoing work. Basically, it's your draft version, basically. And then Git flow tells you how to merge them into master, into your main branch. It's basically a protocol that's being written out. We've instantly, or at least we've decided quite uniformly on no direct changes to develop allowed. So we have a feature branch that is where the developer works on his code, and you have to merge it through Jenkins onto develop. We have a few checks there. So we do have some automated quality assurance. We run the tests, which are now automated. And Autoport has to run successfully. Now, Autoport meaning the three steps that we just had. So build Java, run Autoport, run Sharpen, and build .NET. There are some other things that are included in these merge pipeline things, but once everything builds correctly, these are the three biggest steps. Once everything builds correctly, and you get a green check mark on your build, then it automatically merges into develop. So right now, a developer spends his time writing Java code. Then he goes to Jenkins, he runs the build, and then if he gets a green light, then the changes are automatically merged into our draft version, basically. So there's very minimal C# writing anymore, unless you have the fortune to start writing, to have the change take place in a manually ported file. This has led to quicker release times, quicker development times, more uniformity in our C# repository. So overall, it's a wonderful thing that we've implemented. On the next slide, I've got a brief overview. Not sure if it's completely legible, but I'll just go over it. This is a timeline of things that we've done up until today or last year. And the main ones are going from visual tests to automated tests. So we started using the testing frameworks to their full extent, and not just on a local machine. As you can see here, release Java is manual. The release.NET took 1 extra month, which we shaved down to 1 or 2 weeks with semi-automated releases. We do have a release procedure. We have release pipelines which push that down even further. Right now, we release every 3 months, I think, or 4 months, and the release always goes by so quickly that I miss it that somebody released it. Basically, that's how quick it goes. And then there are some stuff that we're looking to improve in the future, which is food for thought in a different presentation, some certain technologies that we use for testing. We do have some testing specific talks, and we can talk about things in chat as well. Okay, before I exit the presentation, or at least switch back to the chat so I can see any questions that came in. Thank you for listening. We do have a booth in the event. Make sure to check it out. I will be there for about half an hour to 45 minutes, taking any additional questions that I can't answer in the time that I still have left right now. But thank you, and make sure to visit us at our booth. Thank you. Let me check if there's any questions. So there's a question from Nathan. Are you familiar with IKVM? How does Sharpen compare to IKVM? I'm not familiar with IKVM, but I assume it's also a transpiling or a translation language or tool. I'm more than happy to check it out after the talk, but I have no idea. Sharpen was not introduced by me. I am a user of it, and it was configured by a colleague of mine. So I haven't compared it to IKVM. I assume there were some reasons why they used Sharpen over IKVM, but I couldn't tell you at this point. But I'm more than happy to check it out after the talk. If you want to join our booth, my colleague Madeline posted a link to it. Just click it in the chat and we can chat after the session. Okay, Marcus, I think there won't be any more questions, so maybe we can round off here. Okay. Okay, thank you, everyone.
Thank you, Michael, for your talk today. Attendees, please navigate to any available session to the top on your left. Have a great conference.
Thank you, Marcus.
Thank you.